While you sit quietly in your room, your entire world is falling through the dark at more than 2 million kilometers per hour. Earth is not floating gently in place, and neither is the gigantic spiral galaxy we call home. Our entire Milky Way, along with billions of suns and trillions of planets, is being dragged toward an unseen point across the deep universe. Nobody built the road we are on, and for decades, nobody even knew where we were heading. If you love exploring the darkest, most mysterious corners of real science without any fake drama or exaggeration, make sure you hit the subscribe button right now. Join our curious community of space explorers so you never miss another journey into the unknown. For a very long time, humans thought our galaxy was everything that existed in nature. Ancient watchers looked up at the night sky and saw a pale, milky band of light stretching from one horizon to the other. They told campfire stories about rivers of milk, paths for spirits, and silver dust scattered across a giant black dome. Even when the first glass telescopes were built a few centuries ago, people believed that everything in space was locked inside this one single family of stars. In 1920, two famous astronomers named Harlow Shapley and Heber Curtis held a historic debate about the size of the universe. Shapley believed that the Milky Way was the entire universe, while Curtis argued that faint smudges in the sky were separate, distant galaxies. Neither man had the physical proof to settle the argument, leaving humanity completely in the dark about its true place in the cosmos. That simple view of reality was shattered in 1924 by an astronomer named Edwin Hubble. Working at the Mount Wilson Observatory in California, he pointed a massive telescope toward a faint, fuzzy cloud called Andromeda. By measuring special pulsing stars known as Cepheid variables, he calculated that this small smudge was not a cloud of gas inside our galaxy at all. It was another complete galaxy, containing hundreds of billions of stars of its own, sitting millions of light years away across a dark ocean of empty space. Suddenly, the universe grew from a single cosmic island into an endless ocean filled with billions of islands. Our Milky Way was not the center of creation, but just one ordinary spinning wheel of dust, gas, and stars. Once scientists realized there was an outside world beyond the edge of our galaxy, they immediately asked a very obvious question. What happens if you leave the edge of our galaxy, and what is actually waiting for us out there in the deep black? To answer that question, we first have to understand what the edge of the Milky Way actually looks like. Many people picture a sharp border, like the coastline of an island, where the land stops and the water begins. In reality, a galaxy does not have a solid wall or a clean fence to mark where it ends. Instead, the bright disk of stars slowly thins out over tens of thousands of light years until the space between individual stars becomes terrifyingly wide and quiet. Astronomers divide our galaxy into several distinct layers that fade gradually into empty space. The bright center where most familiar stars live is called the thin disk, which measures about 100,000 light years across. Surrounding this bright disk is a wider, fainter layer called the thick disk, where older stars drift slowly in wider orbits. As you travel outward past the thick disk, the familiar patterns of constellations disappear completely, leaving only isolated pinpricks of light in a silent void. If you traveled out past the bright spiral arms, you would enter a ghostly region known as the galactic halo. This is a massive, faint sphere of ancient stars and glowing gas that wraps around the entire main disk of our galaxy. The stars here are some of the oldest objects in the universe, formed shortly after the Big Bang itself. They drift alone in the dark, separated by gaps so vast that a single beam of light takes centuries just to jump from one star to its nearest neighbor. Floating inside this outer halo are giant ball-shaped clusters of stars called globular clusters. Each globular cluster contains hundreds of thousands of tightly packed ancient suns held together by their mutual gravity. These sparkling spheres orbit our galaxy like tiny moons circling a giant planet, serving as the outermost outposts of our stellar territory. Beyond these clusters, stellar encounters drop to zero, and normal visible matter becomes almost entirely absent. Wrapping around all of these visible stars is an invisible giant known as the dark matter halo. Scientists cannot see dark matter directly because it does not emit, reflect, or absorb any light whatsoever. However, by measuring how fast stars orbit around the outer edges of the galaxy, researchers proved that this invisible sphere contains up to 90% of our galaxy's total mass. This dark matter halo stretches out into space for hundreds of thousands of light years, extending far beyond the faintest visible star. Wandering through this outer halo, you would also encounter long, ghostly rivers of stars called stellar tidal streams. These streams are the ripped-up remains of smaller dwarf galaxies that wandered too close to the Milky Way millions of years ago. Our galaxy's powerful gravity acted like a giant meat grinder, shredding these small companion galaxies and stretching their stars into long ribbons that wrap around our outer borders. Beyond the halo and these gas streams, you would look back and see our home galaxy in its full, breathtaking glory. It looks like a glowing pinwheel of blue, gold, and white light, spinning slowly in complete silence. But if you turn your ship around and look outward into the direction we are facing, the view becomes chilling. You are now standing in the intergalactic medium, the true deep space that separates galaxies from one another, where matter is so rare that a cubic meter of space might contain only a single wandering atom. Astronomers originally expected this space beyond the galaxy to be peaceful, quiet, and slowly expanding in a smooth, predictable pattern. Since Edwin Hubble discovered that galaxies are moving away from each other, everyone assumed that cosmic expansion was uniform everywhere. If the universe was just smoothly blowing up like a giant balloon, every galaxy should simply drift outward in a straight, orderly line without any weird side-to-side motion. What they actually found in the 1970s and 1980s completely shocked the scientific world. When astronomers mapped the faint leftover heat from the Big Bang, they noticed something very unusual. One side of the sky was slightly warmer than average, while the opposite side was slightly cooler. This temperature difference proved that our galaxy was moving at high speed, compressing light waves in front of us and stretching light waves behind us. When astronomers converted this color shift into actual numbers, the math did not make any sense at all. We were not moving outward in a smooth, straight line with the expansion of the universe. We were sliding sideways at an unbelievable speed of 627 kilometers per second, which equals more than 2.2 million kilometers every single hour. Think about how fast that really is for a moment. At that speed, you could travel from the Earth to the Moon in about 10 minutes flat. You could fly completely around the equator of the Earth in less than 1 minute. An entire cosmic system weighing more than 1 trillion times the mass of our Sun is rushing through space at breakneck speed, pulled by an invisible force that scientists had never seen before. Why does this massive gap between theory and reality matter so much to us? Because something out there in the deep dark has enough gravity to pull thousands of entire galaxies across hundreds of millions of light years of space. Whatever is doing this must be impossibly huge. Yet when astronomers first looked toward the direction of our flight, they could see absolutely nothing. Did you realize that our entire planet is hurtling through the dark right now toward an unseen point in deep space? What do you think could possibly be strong enough to pull thousands of galaxies at once? Drop your best guess in the comments below, and give this video a quick thumbs up if you love mind-bending cosmic mysteries. The reason scientists could not see what was pulling us is one of the most frustrating coincidences in astronomy. The Milky Way is shaped like a flat, dusty dinner plate, and our solar system sits inside that thick disk. When we point our telescopes toward the direction where our galaxy is heading, our view is completely blocked by our own galaxy's thick clouds of starlight, gas, and dark dust. Astronomers call this blind spot the Zone of Avoidance, and it covers about 20% of the entire night sky. For generations, this region was a complete black box on our cosmic maps. It was as if you were sitting inside a house with thick curtains on the front windows, knowing there was a giant monster walking across your front lawn, but being completely unable to look outside and see its face. Every time optical telescopes tried to photograph this region, starlight was absorbed by thick interstellar dust lanes. The dust particles are microscopic grains of carbon and silicates, but when you look through thousands of light years of them, they form an impenetrable wall. Astronomers could map distant corners of the northern and southern skies with ease, but the most important direction of all remained an unsolved enigma. It took until the late 20th century for researchers to invent tools that could peek behind this thick curtain of dust. Astronomers began using powerful radio telescopes and infrared cameras that can see right through the dust grains, much like an airport scanner sees through luggage. When the data finally came back from these infrared and radio surveys, astronomers got their very first look at the monster pulling our galaxy. They gave this mysterious region a name that sounds like something straight out of science fiction: the Great Attractor. Located roughly 220 million light years away from Earth in the direction of the southern constellations, Centaurus and Norma, this spot contains a massive gathering of matter. It acts like a giant cosmic sinkhole, pulling our Milky Way, our neighbor Andromeda, and thousands of other nearby galaxies straight toward its center. Scientists originally thought the Great Attractor was simply an enormous, super dense cluster of thousands of galaxies hiding behind the dust. They calculated that it would need the mass of tens of thousands of Milky Ways combined into one area to produce that kind of gravitational pull. But when the first clear infrared images of the Norma cluster inside the Great Attractor were finished, scientists ran into another shocking puzzle. The Norma cluster was certainly large, but it was nowhere near heavy enough to explain the speed of our galaxy. The total mass of all the visible stars and galaxies in that spot accounted for only a tiny fraction of the pull we are experiencing. It was like expecting an anchor to weigh 10 tons, only to pick it up and find it weighs 10 pounds. The gravity was real, the speed was real, but the visible mass simply was not there. This gap between what we see and what we feel meant that something even larger had to be hiding further down the line. Pay close attention to this next detail, because it revealed the true scale of the cosmic web for the very first time. The Great Attractor was not working alone. It was merely a single waypoint on a much longer and more terrifying cosmic highway. In 1989, an Indian astronomer named Somak Raychaudhuri discovered what was really pulling the strings from behind the Great Attractor. While examining photographic plates at the University of Cambridge, he found a massive concentration of galaxies located far beyond the Norma cluster. Sitting more than 650 million light-years away from Earth lies an unimaginable structure known as the Shapley Supercluster. The Shapley Supercluster contains more than 8,000 individual galaxies packed tightly together in a glowing cosmic knot. Its total mass is estimated to be more than 10 million billion times the mass of our Sun, or roughly 10,000 times heavier than our entire Milky Way. The sheer gravity of this megastructure bends the fabric of space and time so violently that it creates a massive gravitational basin, pulling everything in our corner of the universe toward its glowing core. To make sense of how these massive structures fit together, scientists had to redraw our entire map of home. In 2014, a team of astronomers led by R. Brent Tully from the University of Hawaii mapped the velocities of thousands of local galaxies. They discovered that our Milky Way is not an independent structure, but merely a tiny strand inside a gigantic cosmic river called Laniakea, a Hawaiian word that means immense heaven. Laniakea is a colossal supercluster of galaxies, stretching across 520 million light-years of space. It contains over 100,000 individual galaxies, all moving along invisible gravitational currents, like water, flowing down a mountain into a giant lake. The Great Attractor sits right at the heart of this valley, serving as the central gravitational hub where all these galactic rivers meet. If you could zoom out and look at Laniakea from the outside, it would look like a glowing, feathery tree made of pure light. The Milky Way sits out on one of the very faint outer twigs of this giant tree, slowly sliding down the branch toward the heavy trunk. But just when scientists thought they had finally solved the mystery of why our galaxy is moving so fast, another discovery turned the entire picture completely upside down. How does it feel knowing that our entire galaxy is just a tiny drop in a 500 million light-year river of stars? If you are enjoying this journey through the real structure of the cosmos, tap that subscribe button and leave a comment sharing your thoughts. Your support helps us bring more deep space investigations to light every single week. For decades, astronomers had focused entirely on what was pulling us forward. Gravity is an attractive force, so everyone naturally assumed that if an object is moving fast, something massive must be pulling it from the front. But when astrophysicists calculated the combined gravitational pull of the Great Attractor and the Shapley Supercluster, the numbers still did not add up perfectly. The pull was strong, but our actual speed was still higher than it should have been. In 2017, a team of scientists led by Yehuda Hoffman discovered the missing half of the equation, and it was the exact opposite of what anyone expected. We were not just being pulled toward a giant mountain of matter in front of us. We were also being violently pushed from behind by an almost completely empty region of space known as the Dipole Repeller. To understand how nothingness can push something, you have to think about how gravity balances across the universe. Imagine a giant game of tug-of-war, with a team of people pulling on one side of a rope and a team pulling on the other side. If the team on the left side suddenly lets go of the rope, the people on the right side will fly backward, even if they did not pull any harder. The lack of pull on one side acts exactly like a push from behind. The Dipole Repeller is a massive cosmic void sitting directly behind our galaxy, on the exact opposite side from the Shapley Supercluster. It is an enormous desert of space, hundreds of millions of light-years wide, that contains almost no galaxies, no stars, and no gas. Because there is virtually no mass inside this void, it exerts almost zero gravitational pull on anything around it. As a result, the dense clusters in front of us pull hard, while the empty void behind us provides no resistance at all. Our Milky Way is caught in a cosmic wind, pushed away from the empty desert of the Dipole Repeller and pulled toward the crowded metropolis of the Shapley Supercluster. We are surfing across a giant gravitational wave created by the extreme contrast between absolute emptiness and extreme density. This discovery forced scientists to look much more closely at the giant empty spaces that exist between galaxies. For a long time, people thought cosmic voids were just boring gaps where nothing interesting ever happened. But as astronomers built larger, three-dimensional maps of the universe, they realized that these voids are actually some of the most terrifying and important structures in existence. When you look at the large-scale structure of the universe, it does not look like a random scatter of stars. Instead, it looks like a giant sponge or a web of glowing silk made by an impossibly large spider. Galaxies and superclusters form thin, glowing filaments that wrap around enormous dark bubbles of absolute nothingness. These bubbles are known as cosmic voids, and they make up more than 80% of the total volume of the entire universe. The most famous and terrifying of these empty realms is the Boötes void, sometimes called the Great Nothing. Discovered in 1981 by astronomer Robert Kirshner, the Boötes void is a nearly spherical bubble of emptiness located about 700 million light-years away from Earth. It is so unimaginably large that it measures nearly 330 million light-years across from one side to the other. To understand just how empty this region is, consider how crowded our own neighborhood of space is. A normal volume of space that size should contain roughly 10,000 large galaxies, along with trillions of stars and countless planets. Yet inside the entire Boötes void, astronomers have only been able to find about 60 individual galaxies, scattered across that colossal abyss. These fuel-only galaxies are not spread out evenly. Most of them sit inside a tiny, faint tube of gas running through the center of the void. The rest of the void is completely devoid of luminous matter. Scientists believe the Boötes void was formed when several smaller cosmic bubbles merged together early in the history of the cosmos, sweeping all matter out toward its outer edges. If our Milky Way were sitting in the middle of the Boötes void, the night sky on Earth would look completely different than it does today. There would be no bright band of the Milky Way, no colorful nebulae, and no neighboring galaxies visible to our naked eyes. The sky would be pitch black in every single direction, with no light reaching our eyes from any other star system in the universe. Humanity would have grown up believing that our galaxy was the only thing that existed in the entire universe. We would have had no way of knowing that other galaxies even existed until we built the most powerful digital telescopes of the late 20th century. It would have been the loneliest place in the entire cosmos, surrounded by millions of light-years of cold, unbroken silence. What would you feel if you looked up at night and saw absolutely nothing but blackness, with not a single star in the sky? Take a second to write your reaction in the comments below, and if you find these cosmic voids as fascinating as I do, make sure to hit that like button right now. As scientists continued to map the boundaries of these enormous voids, they discovered another shocking truth that hits uncomfortably close to home. In 2013, a team of researchers from the University of Wisconsin-Madison, led by astronomer Amy Barger, published a study showing that our own galaxy does not live in an average normal region of space. We actually live inside one of the largest voids ever discovered in the cosmos. This structure is known as the KBC void, named after astronomers Keenan, Barger, and Cowie. It is a gigantic, sphere-like bubble of low density that stretches for roughly 2 billion light-years across. Inside this massive zone, the density of galaxies and matter is roughly 20 to 30% lower than the average density of the rest of the universe. Think about what that means for our understanding of reality. We are not living in a crowded, thriving center of the universe. We are living out in the cosmic countryside, inside a massive underdense bubble carved out of the cosmic web. This massive local void explains why the universe appears to be expanding slightly faster in our local neighborhood than it does across the deep cosmic background. Because there is less matter inside our local bubble to pull things together with gravity, space inside the void expands more freely and rapidly than the dense regions outside. This discovery helped explain why different measuring techniques produced slightly different speeds for the expanding cosmos. The numbers varied simply because our local bubble is emptier than the average fabric of deep space. Beyond these giant voids and filaments lies an even deeper mystery that scientists still struggle to explain today. In 2008, an astrophysicist named Alexander Kashlinsky, working at NASA's Goddard Space Flight Center, discovered a phenomenon that was so bizarre many scientists initially refused to believe it. While studying the faint background glow of light left over from the Big Bang, his team found evidence of a movement called dark flow. According to standard physics, the expansion of the universe should be the dominant motion on very large scales. Clusters of galaxies should simply move along with the general expansion, without any coordinated sideways drift across billions of light years. But when Kashlinsky measured hundreds of distant galaxy clusters, he found that they were all drifting together in a single coordinated direction, at nearly 1,000 kilometers per second. This motion was not pointing toward the Great Attractor, nor was it pointing toward the Shapley Supercluster. It was pointing toward a specific patch of sky between the constellations of Centaurus and Vela, far beyond the edge of our observable universe. Something outside the boundaries of everything we can possibly see appears to be pulling on an entire section of our cosmos. How could something pull on galaxies from beyond the edge of the observable universe? To understand this, you must realize that the observable universe is not the whole universe. It is merely a bubble of light that has had enough time to reach our telescopes during the 13.8 billion years since the Big Bang began. Beyond that horizon, space continues onward, possibly forever, filled with matter and structures that our eyes can never directly see. If there is a colossal concentration of matter or an uneven density left over from the very first fraction of a second of the universe, its gravity could still reach across the cosmic horizon. It could be tugging on the matter inside our visible bubble, creating a giant current that drags hundreds of clusters of galaxies toward the unseen outer dark. This brings us to a chilling realization about the true nature of space beyond our galaxy's edge. Everything we can see, from the closest planet to the most distant glowing quasar, is locked in a massive, ongoing gravitational dance. Nothing is still, nothing is resting, and every structure in the cosmos is being pulled by invisible threads woven through the dark. While all of these massive, large-scale motions are pulling us across hundreds of millions of light years, a much more direct and violent event is taking place right in our immediate neighborhood. If you step just outside the halo of the Milky Way, you enter a local family of galaxies called the Local Group. This group contains about 80 known galaxies, but almost all of its mass is concentrated in just two giants, our Milky Way and the Andromeda Galaxy. Andromeda sits about 2.5 million light years away from us, glowing as a massive spiral of more than 1 trillion stars. In 1912, astronomer Vesto Slipher measured the light from Andromeda and made a startling discovery. While almost all other galaxies in the universe showed a redshift, meaning they were moving away from us, Andromeda showed a strong blue shift. This blue shift meant that Andromeda is racing directly toward the Milky Way at a blistering speed of 110 kilometers every single second. The gravity between our two massive galaxies has completely overpowered the general expansion of space in our local region. We are on a direct head-on collision course with a giant galaxy that contains twice as many stars as our own. Scientists originally thought this collision might be a glancing blow, or that the galaxies might miss each other entirely and simply swing around one another like dancers. But in 2012, astronomers used the Hubble Space Telescope to measure the sideways motion of Andromeda with pinpoint precision. The results confirmed our worst suspicions. This is going to be a direct, unavoidable impact. In approximately 4 to 5 billion years, the night sky of Earth will change in ways that seem impossible to imagine. Andromeda will grow larger and larger in our sky until its glowing spiral arms stretch from horizon to horizon, filling the dark with billions of alien stars. The giant, supermassive black holes at the centers of both galaxies will begin a violent dance, sending massive shockwaves through the gas clouds of both systems. Does the idea of our entire galaxy colliding with another trillion-star monster make you feel tiny? If you want to keep exploring the future of our universe together, take a moment to subscribe right now and ring that bell. Leave a comment below with your favorite cosmic fact so far, and let's keep the discussion going. When this collision finally happens, the result will not be the destruction of individual planets, because the space between stars is so vast that actual star-on-star collisions are extremely rare. Instead, the two spiral disks will be ripped apart by gravitational tidal forces, throwing millions of stars out into intergalactic space like glowing sparks from a campfire. Over hundreds of millions of years, the two giants will merge into a single giant egg-shaped structure known as an elliptical galaxy, often nicknamed Milkomeda. This future merger is a preview of the ultimate fate of everything that lies beyond the Milky Way's edge. In 1998, astronomers discovered that the expansion of the universe is not slowing down under gravity, but is actually speeding up. This runaway acceleration is driven by a mysterious force known as dark energy, which makes up about 68% of the total energy density of the cosmos. As time marches forward, the dark energy that drives the acceleration of our universe will continue to stretch the fabric of space faster and faster. And while our local family of galaxies merges into one giant supergalaxy, all the distant superclusters and filaments will be pushed away from us at speeds faster than light itself. Eventually, every other galaxy outside of our merged local group will cross the cosmic event horizon. Their light will become stretched, reddened, and dimmed until they fade completely from view. An observer living on a planet around a star in the far future will look out into deep space and see absolutely nothing beyond their own single galaxy. All the great structures we have mapped today, the Great Attractor, the Shapley Supercluster, Laniakea, and the Boötes void, will vanish into the permanent dark. Future astronomers will have no telescope powerful enough to detect that those structures ever existed. They will once again believe, just like ancient humans did thousands of years ago, that their single island of stars is all that has ever existed in the universe. We happen to be living in a golden temporary window of cosmic history. We live at a time when the universe is old enough to have formed complex stars, rocky planets, and conscious minds capable of asking questions, yet young enough that the light from the rest of the cosmos can still reach our eyes. We can look out past the edges of our home galaxy and witness the vast, terrifying machinery of the cosmos at work. We can see the great rivers of light flowing toward unseen centers of gravity. We can map the giant voids where silence reigns for hundreds of millions of light years. We can feel the gravitational tug of structures so enormous that they challenge our deepest understanding of physics and reality itself. When you walk outside tonight and look up at the quiet stars, remember what is really happening beneath that peaceful view. You're not standing on a solid rock resting safely in a calm universe. You're standing on the surface of a world flying through the dark, carried by a river of 100,000 galaxies falling endlessly toward the unknown. If you enjoyed uncovering the terrifying truths of what lies beyond our galaxy's edge, please take a second to hit that subscribe button, turn on all notifications, and share this video with a friend who loves deep space mysteries. What part of this cosmic journey surprised you the most? The Great Attractor, the giant Boötes void, or our future collision with Andromeda? Let me know your thoughts in the comments below. Thank you so much for watching, and keep looking up into the dark.